Hello and welcome to our Regex community. In first video we covered Regex fundamentals. Now I like to start with some real DLP challenges. Before I begin I need to emphasize that Regex is incapable of any type of calculation or validation per se. In most DLP software when defining a rule, you will have a part for validation. Not all DLP solutions have the same validator, some are weak and some a bit more advanced. Let me give you an example. If the task is catching USSSN, the regex would be catching 3 digits number, dash, 2 digits number, dash, and a 4 digits number. You can think of many numbers, between 0 and a billion. In SSN, the first 3 digits is called area number. The next 2 digits is called group. And the last 4 digits is called serial number. In area number 000s or 666s are not valid, also they cannot be between 900 and 999. In group also 2 zeros are not valid. The 4 digits serial number also cannot be all zeros. Last 2 rules for the whole SSN is that they cannot be all same, like all ones, or sequential like 1 2 3 4 5 6 7 8 9. USA SSN can be handled by Regex. Canadian SIN also has restrictions. Like USSSN, they cannot be all zeros and they cannot be sequential. Canadian SIN number must also pass the Luhn check, which cannot be handled by Regex. Some DLP applications have this option, Microsoft Purview is one of them. Some other applications only have simple checksum. We have the same situation when we deal with credit card numbers. They also have many restrictions and rule which needs to be validated after the match. With no validation we can catch millions of false positives. Finding and isolating false positives is indeed a significant hurdle, as false positives are often indistinguishable from true positives to automated systems. I repeat, false positives are often indistinguishable from true positives to automated systems. They waste resources, cause alert fatigue, and potential misdetections. In real DLP scenarios, most of the efforts are focused on lowering the false positives. And unfortunately, out-of-the-box sensitive information types or dictionaries are not very well vetted, and the rate of the false positives can go up to 80%. If working with any specific tools, make sure you find out what validation options the tool is offering. Options such as Luhn check or checksum validator. Technically you will end up creating custom dictionaries or sensitive information types for 2 reasons. First, the weaknesses of out-of-the-box sensitive information types or dictionaries. Second, when there are no out-of-the-box sensitive information type or dictionary designed for your specific needs. Very important takeaway. If you are designing a pattern in your environment which requires validation, adapting your design based on the available features for validation in your DLP solution is paramount. In the other words, design something you can implement or modify your design the way it can be supported by the tools you are using. Regex is also widely used in programming languages. You can use them in Java, JavaScript, Python, Perl, C, C++, PHP, Ruby, .NET, and PowerShell. Using a programming language for Regex has also its own challenges. No DLP software provider allows you to use it in their environment. Disappointing, isn't it? I like to challenge you with a question. Why DLP programs are designed in the first place? Please send your thoughts in comment area, the correct answer may shock you. In this video I will focus on one real example for catching what we need, but validation depends on the software you are using. In my future videos I will use PowerShell, which can match and validate in case you are a programmer in need of using Regex. Without any further delay, let's start with an interesting example. Matching phone numbers is what you may have seen in many training video or articles. The reason I picked this item is because it correlates with my first video regarding Regex fundamentals. I have prepared some examples and I'm going to create a pattern. Let me clean up the test string area and paste the example texts first. Numbers has different format, local and international. Now I paste the first pattern. 3 digits. Space or dash. 3 digits space or dash and 4 digits. The pattern works, but the same number with country code is not matched. The numbers between parentheses are not matched either. All country codes starts with plus sign, followed by 1, 2, or 3 digits. I recommend you to pause and see if you can fix the pattern to address that. Now we need to address the example in which the first group surrounded by parentheses, and also those with country codes. I rather to catch them separately for more clarity. Give me a second to paste the pattern. Literal open parenthesis if any, 3 digits. Literal close parenthesis. As illustrated, with this pattern we matched all 3-digit numbers between parentheses. Now it's time to catch country codes separately. Give me a second to paste the pattern. With this pattern we are matching all country codes which can be 1, 2, or 3 digits and starts with plus sign. Plus sign is special character, and in order to catch it we need to escape it by using backslash. Let's go through it. Literal plus sign. 1 to 3 digits. As illustrated, all numbers indicating the country code are selected. So far we created 3 patterns. Now I will paste the pattern which demonstrate how we put local numbers and local numbers with parentheses together. It takes a second to paste. It starts with a non-capturing group using question mark and colon. We are non-capturing 3 digits between parentheses. The rest are group of 3 and 4 digits. We matched all local numbers with or without parentheses. Now let's see if we can match only numbers with country codes. Let me paste the pattern. This pattern also starts with a non-capturing group and matching plus sign followed by 1 to 3 digits. The rest is the groups of 3, 3, and 4-digit numbers. Now it's time to put them all together. I'll paste the pattern in a second. Voila! We covered all of them. Please pay attention to the question mark at the end of each non-capturing groups. This sign makes them optional. Phone numbers can appear in different patterns. They are not always 3 digits. 3 digits. 4 digits. I paste the different possible formats so you can get the idea. I leave that to you to figure it out if you have a special case to deal with. Please leave a comment if you want me to make a video about the specific case you are dealing with. I'll do my best to answer. Until next video. Ciao.